Hey, how's it going? So today we're gonna do LeetCode in order successor in BST. Two of so this question. So given a node in a binary search tree, find the in order successor that of that node in the BST. If that node has no in order successor, return none. The successor of a node is the node with the smallest key greater than node of value. You will have direct access to the node, but the root of the tree, each node will have a reference to its parent node. Below is the definition of the node. So basically, this in-order successor in BST2 is different from the in-order successor of BST1 because we have access to the parent node. So that's actually make this thing easier because let's look at this example. What's the in-order successor of node 1? It's 2, right? So what's the in-order successor of 2? It's 3, right? It's the smallest number that is greater than the node. What is the in-order successor of 3? It's 4. What's the in-order successor of 4? Is 5, right? What's the in-order successor of 5? Is 6. What's the in-order successor of 6? It's none because it's done at the last node in the in-order traversal, right? So we can see that if a node has a right tree, right, it means that it has something larger on the right tree. So we just need to explore the right tree. So if, let's say 4, if there is something like, let's say 4.5 in the left subtree, basically if we want to find the node of node 3 successor, we have to, if it has a right subtree, we know that the successor will be somewhere inside the right tree, right? And if the 4 has a left subtree, we have to go left because we know that somewhere here in this right subtree it has the successor, and we have 4 here. So if there's something smaller on the on 4, we have to go left until we reach the leftmost node, right? And we return that node. So that's our first case. So if the node we're looking for has a right subtree, let's write it down first. So the node we're given is the node that we want to find the successor to. So if node has a right subtree, if it's not known, then we basically traverse. We go to the right tree, right? So this is how you traverse from 3 to 4. And once we're done here, and while node.left, so basically we're saying if there's any subtree, left subtree of the 4, we have to go to the leftmost node, right? And all we need to do at this point is return node. So if there's let's say if there is a left subtree here, 4.5, then we go to the 4, and while it has a left subtree, so if there is a 4.5, node equal to node.left, so we go to node 4.5, and at this time we just need to return node. Okay, that's our first case where the indentation is a little bit off. That's our first case where node has a right subtree, right? What if the node doesn't have a right subtree? For example, the 161 doesn't have a right subtree. So we know that it has to go to the parent, right? So we know the answer is 2. For 2, the answer is 3, right? For 4, it doesn't have a right subtree. Its answer is not 3, but it's 5. So basically, we want to go to its parent node until the parent's value is larger than the node, right? So for example, here, 1, we go to the parent, and parent is greater than the node, then we return the parent, right? So for 2, it doesn't have a right subtree. We go to its parent, and we find the parent is greater than itself, so we return the parent. And for 4, it doesn't have a